today all we're doing is like application, but it's not even really application. It's like reading some words, coming up with your equations, then doing the same things we've been doing so far. It's not super challenging. Later on, I'm going to give you some more harder ones that do get harder, but today's aren't horrible. So I think you can handle this. Today we're going to do this. We're on page 641. Monday, you're going to have a work period. I'm not here Monday. Someone else is here to cover for my class. I have no idea who. And you're just going to have a work period. I have an assignment I'm going to give you. That's a hand-in, just practice questions assignment for you to work on, but you'll also have time to work on some of this stuff too, okay? So right now, there are 3 different ways to solve the system equations: by graphing them and using your calculator. So using your graphing calculator, requirement for this unit. By substitution and by elimination. By all means, you can have a favorite method, but on like your unit test and like moving forward through school, you do have to know how to use all 3 methods. Depending on the question, one method may be easier than the other as well. Generally speaking, we will always specify how we want you to solve, but especially we'll say solve using graphing, or we might say using algebraically. If we say algebraically, that means substitution or elimination. Can't spell. And then if we just said algebraically, you could pick like the method of choice. But showing. Oh, I didn't share my screen. Yes, sorry. So problem solving, you need to introduce your variables. You need to tell me x is going to equal this, y is going to equal this. Choose x and y, they're the easiest to read, but by all means, you could pick like A, B, C, whatever letter your heart desires. Draw heart for that matter, I don't care. Then you're going to form your system, you're going to solve it, and potentially check if the question tells you to. So this is like reading, interpreting. If you said interpret the question wrong, that's on you. That's part of the math, which is unfortunate. But usually they're pretty clear. The difference between 2 numbers is 9. The larger number is 3 more than twice the smaller number. Find the numbers. I hate questions like this. They're like that someone bought 30 watermelons at the store, but that's okay. Let's say, so step 1 is to define our variables. Your definitions are fairly like, I don't want to say simple, but it's like in common language. So like x is going to represent the larger number. Therefore, y is the smaller number. Knowing that, and generally speaking, each sentence in the question represents an equation. That's a good kind of strategy to keep in mind. The difference between 2 numbers is 9. 9 is a positive, so likely it's my larger minus my smaller. Why do I say likely? Good, good, right on, because we could have negative numbers there. So that's why we say likely. My second equation, the larger number is 3 more than twice the smaller number. How could I write that one? So is often equals. Go ahead, Jacob. Yes. Then what?
Because like the large number is 3 more, or plus 3.
Good. Equals x. So x is our larger number. Twice the smaller number is our 2y plus 3. You could write that in a slightly different order. Totally fine. Okay, do you guys want to use substitution or elimination? Substitution. Let's do substitution on this one. We can do elimination next. Substitution, our step 1 is solve for one of your variables. So like this is my system right here. The second equation already is solved. It already equals x. So we can plug that into my first equation very easily. So we can rewrite this to be 2y plus 3 minus y equals 9, being that my original equation was x minus 9. What's 2y minus y? y. So then I get y plus 3 equals 9, minus 3 from both sides. Y is equal to 6. Am I done? No. Then we have to plug that back in to whichever equation your heart desires. Why not do it the one that's already equal to x? So then I get 2 times 6 plus 3. So 12 plus 3 is 15. So you can write out your answers like that, x equals, y equals. Because we used x's and y's, we could also write it as a coordinate pair. Whichever you prefer. How do I check this? Go ahead, Sophia. Is your hand not up? Yeah.
You would take your x and y values and put them into both.
Good. Has to go into both. Can't just go into one. Let's turn the page and go into the next one, though. Do you guys need a second? I feel like that kind of happened fast. Questions like this one are much, much more common. This would be like a really good level 4 question. Perimeter of a rectangle is 40 meters. The width is 4 meters less than the length. Find the dimensions of the rectangle. So let's draw a rectangle. Sometimes a visual is super helpful. Let's say this is y and this is x. That can count as defining your variables. I've matched them to a diagram. We don't know which one's going to be my bigger or smaller one. Length should always be your longer side. So that's why drawing a picture can be helpful that way. What would my first equation be? Sorry, go ahead, Jacob. No. Khalil, do you want to try? No. How do I calculate perimeter? Go ahead, Audrey. Just one, but yes. No. Jasmine. Good. Perimeter. I'm going to add each of the two sets of sides together. 2 x's and 2 y's, that gives me my total perimeter. By all means, you could use L and W, right? That would also be a very logical thing. Okay, that's our first sentence. The perimeter of a rectangle is 40 meters. Second sentence, the width is, so depending how you want to do it, but let's say I kind of drew it so my width was y. So my width is 4 meters less than the length. So that means what? So go ahead, Paisley. Good. Because the width is 4 meters less than the length, implies we're going from our length, subtracting 4. Right? Yeah. What's really hard with this is little things like that. What will happen, though, if you put it in wrong initially, you'd get a negative length. And then it'd be like, clearly you did something wrong. Okay, this question, I know I said we'll do elimination. Do you guys see why this question would be much easier with substitution, though? Good. My y is already solved for. So a lot of the times, like choosing your method, choose which one's ever easier. That being said, some of you might like despise substitution with all your heart, and it's worth doing the extra couple of steps in elimination. That's fine. I don't care. Do your math right. Do what works for you. But I would agree substitution's easier here. I've already got y solved for. So I'm going to start using our first equation of 40 equals 2x plus 2y, and I'm going to substitute in my value for y. So I get 2x plus 2 times x minus 4. Oh, you were, I see. Yeah, I see what you're saying. I was really confused how you got up with yours. I was like, what is happening here? Okay, so then I'm going to multiply in my 2 into both one of these. I'm just doing my distributive properties. So then I get 2x plus 2x minus 8. Combine like terms. So 40 is going to equal 4x minus 8. Add 8 to both sides. So then I would get 48 equals 4x. Divide both sides by 4. And I get 12. So it happened totally by like fluke. I drew it right, that x is longer, right? Then I'm going to solve for y. So y is equal to x minus 4. So 12 minus 4. Y is then equal to 8. How's that? Could you have done this with trial and error? Yeah. Depending on the values and the numbers, trial and error could be really quick. But trial and error could also take you forever. Substitution or elimination, but solving via a system is like a way that you know how long it's going to take you always. We want you using one of these methods, but in theory, you totally could probably play with it long enough to get 2 values that would work. Okay, money applications. These ones really tend to mess with you guys, but they shouldn't be as difficult as they are. We're going to do 2 of them. Well, it just like, they're not that difficult, but like you guys mess quarters up. You say like a quarter is worth 5 cents. Like you make money errors. It's a struggle. Exactly, yes. 5. Yes.
When people call people a dime, does that mean they're like a 10? Like it's a 10 out of 10? That's funny. I didn't know that.
Okay, so Gary has a total of $260 in $5 bills and $10 bills. Why? Who knows? If he has 33 bills in total, how many of each denomination does he have? Do you guys know what denomination means?
No.
It's just like each type of bill. Denomination is like the fancier word. So first step, let's define our variables. So X is our number of, let's do $5 bills. So we're actually talking about the amount of bills at this point. We're not talking about values yet. So then Y is going to be the number of $10 bills. That would have been good. But it would really mess with you guys. Who could give me what one possible equation could be? Jasmine. Yes. 260 is a dollar amount. So then if I go 5 times the number of $5 bills, I get a dollar amount, plus 10 times the number of $10 bills, I also get a dollar amount. So all of these like portions or all these terms represent a dollar amount. What would my second equation be? Go ahead, Jasmine. $33 equals X plus Y. It's too much. Where did I get 5 from?
It's because 5 is like what it's like in money. Oh
Yes.
my God. What is
So
happening?
this first equation, we're talking about the value, so an actual dollar amount. The second equation is like the number of bills. Sometimes it might be a number of coins.
Wait, and then
Then,
not the substitution is easier.
The elimination?
Yeah.
Yes. Okay, so let's do elimination. Let's times everything by 5. So times 5 times 5. So I'm going to draw a little line. 33 times 5 is 165 equals 5x plus 5y. I'm going to rewrite my first equation, which is now going into the second equation spot. Is that okay? Can you guys handle that? So I get 260 5x plus 10y. Do I want to add or subtract these? Okay. Then we get negative 95 equals 0x and minus 5y. You don't have to write 0x. I'm just doing it to prove, like, to really iterate that. Then, just to clean it up, negative 95 equals negative 5y. Divide both sides by a negative 5, so my negatives cancel, because that would be really bad if we got a negative. Y is then equal to 19. Oops. So he has 19 $10 bills, which is absurd. Yep. So now we're just going to go, like, in short terms, 33 minus 19. Right? Really, am I using my equation? Kind of, but not really. I'm just kind of skipping steps, which gives me 14 equaling our x. What I did there, just to, like, confirm for you guys, I used 33 equals x plus y, and I substituted it back in. Right? I would minus 19 on both sides. I'm doing that same step. I am totally fine with you guys doing it that approach. Quite frankly, that shows me that you're really understanding what's going on and not just following a process. Both work, though, for me. Okay, last one. We're coming back to percents. It's okay. Laura, it's okay. I'm going to hold your guys' hands. You can do this. Laura invested her inheritance. Lucky girl got an inheritance of $48,000. You could. Laura invested her inheritance into two, thank you, Drew, I agree, in two different mutual funds. At the end of 1 year, one fund had earned 10.5% interest, which is really good, just so you know. The other fund earned 12% interest. If she receives a total of $5,520 in interest, how much did she invest in each mutual fund? You don't know what interest is? Do you guys not? So interest, so what happens when I put my money in a bank, they actually spend the money. And they put it into different investments and different bonds, and anything they make from it, I gain that money. But at the same time, you could lose money. So it's kind of a gamble of investing. So, but I could put in 10 grand and make whatever interest off it, and then I get 10 grand plus my interest money. So then I could, like, close down my account and just take off the free money I earned, which is pretty sweet. Yes?
How do you launder money?
I don't know. I don't know.
You need like a front. You have to, it's like an excuse for like the amount of money you got because they're like, where's the money? I don't know what that is.
Okay, so X is our money invested in one account. Sure, do you want A and B?
No, I want an account.
Okay, in account A.
No.
No.
Y is going to be money invested.
I got it. X plus Y. Am I on to something? Am I on to something?
Yes.
Oh!
So, yes.
Is it 10 points?
So we're going to have our first equation. She has $48,000. Money in account A plus money in account B should hopefully equal 48,000, or else she's made some big mistakes. Right? She's taking that money, only putting it into two places. Does that make sense? Okay. We now have our percents and this interest amount. So what you have to do on this second one, we know in total she made $5,520. Doing nothing. Like she went to the bank. Quite frankly, you can do this over email. So she emailed her banker and was like, do this for me. Did an e-transfer, and she made $5,000 doing nothing. Like investing is sweet. So in the first account, she made 10.5% interest. Remember, when you're working with percents, you have to move it to a decimal. 0.105 x plus 0.12 y.
I got it. Probably the reason why you wouldn't like combine like the total number and then like the interest number and have like a total and then you just like do it.
Because if you did it that way, so you could and have a total number, you're not going to come up with two separate equations. You would come up with like one giant scenario, which is true and which is like a valid statement, but then you don't have two equations, which means you can't solve it.
Okay.
That's a really good question, though. Really good question. Okay, do you guys want to do substitution or elimination? Elimination. Okay, so if we're doing elimination, let's multiply. Let's do elimination. Let's times this first one by 12. Because then I get 12y. Let's times our second one by 100. Okay. So my first equation, I'm timesing everything by 12. My pen's not writing. Everything by 12, and then everything by 100. So we're going to get 5,700, oh my God, 576,000 words. It's equal to 12x plus 12y. Yes. Yes, you're definitely allowed calculators. My second equation, 552,000 timesing by 100, so then I get that 10.5 plus 12y. So from here, I'm going to subtract both of these because then my y's cancel out. Subtract, and I get a difference of 24,000. 12 minus 10.5 gives me 1.5 x's. Then I divide both sides by 1.5. So into her first account was $16,000. How much went into her second account then? Good. So 48,000 was x plus y. Good. So then that's 16,000 plus y. Subtract 16,000 from both sides. There's a lot of money. Let's hope it was her great-grandmother. by all means, you will have to do some checks. I don't think they give you a lot of work space, so I'm not going to make you do the check and plug it in.
You're so funny.
You guys are so funny.
Be like, well,
Okay,
You know what? Not very catch.
so these, oh my